we have this definition of continuity of a function at a number. It says that a function f would be continuous at a certain number, say a, if and only if the following or these three conditions right here are being satisfied. That is, if f of a exists, the limit of f of x exists as x approaches a, and later on, whatever our answer is at the first condition, it should be equal to the second condition, so we can conclude that the given function is certainly continuous at the number a. So to picture this out, let's have these two examples right here. Say we have f of x to be equal to this piecewise function, 4 minus x squared, if x would be less than or equal to 1, and we have 2 plus x squared if x would be greater than 1. So in here, our a in this given would be 1. So let's check that. Now, let's get some sheets to have more space in answering this. So let's have our question here. Is f of x continuous at 1 if f of x would be the piecewise function 4 minus x squared if x is less than or equal to 1, and 2 plus x squared if 1 is less than x. There. So that's our question. Now again, we have to satisfy these three conditions here. So let's check first if f of a exists. That is, can we look for a number, an answer when we try to solve for f of a? So let's try that first condition. So for the first condition, what's our f of a? A again is 1 here. So what's f of 1? Can we have an answer for f of 1? Let's check. Do we have here a domain which is being considered if x is equal to 1? Definitely we have that, and that would be for this function right here, right? It says that we are to use this function if x is less than or equal to 1 there. So f of 1 would be based now from the function 4 minus x squared. So in that case, this would now be equal to 4 minus our x here is 1, so that would be 1 squared, which is still 1, and our answer here is 3. So does f of a or f of 1 exists? Definitely, and that would be equal to 3. Now moving to the second condition would be this time verifying the existence of the limit of f of x as x approaches a. Now how again to check or to know if the limit exists? I hope you can remember that. Limit of f of x exists if and only if, and that would be equal to L, whatever L is. That is, if we'll try to check the left-hand limit of the function as well as the right-hand limit, and both of them should be equal to L. So going back here, we have to check if the limit of f of x from the left and from the right would exist, and we should have a specific number there, right? So in this case, we have to check the limit of f of x. Say, let's start with as x approaches 1 from the left. There, from the left. So I hope you can remember this. So from the left of f of x, from the left of 1, what domain to consider? Should it be this domain right here or this domain right here? In left of 1, so that would be numbers less than 1, or the x's here would be less than 1. Alright, so clearly that should be this domain, right? The x at the left of 1 would be this. So we are to consider now that 4 minus x squared. And how to do that one again? I hope you can still remember. We just have to substitute the 1 here, right? For that 4 minus x squared. It's different when we are having infinite limits. again, when we do infinite limits to a point that we have to substitute a certain number that would be close enough to the number here from the left or from the right, that is, again, if we are considering infinite limits, or we have a denominator that would be equal to 0. So in this case, that's not definitely the case. So we don't have to do that thing. We don't have to look for that close number, close enough to this one. We'll just have to substitute right away 1. I hope we can, differentiate the cases here. There, so substituting 1 for that 4 minus x squared, that's actually what we did in the first condition. So this would be now equal to 3. Now how about the right-hand limit of the f of x? So the right-hand limit of f of x here, that would be written as this. So clearly, x's at the right of 1 would definitely be this domain right here. That would be x greater than 1. So this time, our function to be considered would be 2 plus x squared. So what happens there? That would be 2 plus our 1 here to be squared, which is still 1, gives us 3. And it says that again, the limit of a function exists and would be equal to L if the left and right hand limit are equal to each other. And that limit would be that value that we just solved. So in this case, we have 3 right here for the left hand limit, and as well as, that's the same for the right hand limit. So therefore, for this case, for the second condition, the limit of f of x actually exists. That would be as x approaches 1, and that is definitely equal to 3. There you go. So moving now to our third and last condition. Our third condition says that we have to have the answer at our first condition, that f of a, be equal to our answer at the second condition, that would be this part right here. If that would happen, then definitely the function would be continuous at the number a. So in this case, if we'll get that solution that we have, our answer to first condition is 3. So f of a is equal to 3, and that is definitely equal to the limit of f of x as x approaches 1. So what's our final conclusion this time? Therefore, f of x is definitely continuous at 1. There you go. Okay, have a glimpse of our solution. So, as an exercise, please try answering the second function right here, and please comment down below. Inform me what you're having problems with, or ask me if you're doing the right thing, if your solution are right, and just post your answers or just inform me, yes, through commenting down below or during our practice day. All right, I actually have 2 A's right here, so you have to check continuity for 2 numbers here. Please try to check if it's continuous at 3, and please also check if it's continuous at -3. There, so please give me 2 answers, 2 sets of solutions, and that would be one that would answer if it's continuous at 3, and the other one would answer the question if it's continuous or discontinuous at equals -3. There you go. So again, please inform me, comment down below if you're having problems with, and I definitely would love to assist you guys. All right, thank you for listening, thank you for watching. I hope to see you in my other videos.